All right, here we go. February the 5th, our new daily challenge for today. It's Friday. It might be a little bit harder problem today. Who knows? All right, let's first check any comments that we need to address. Looks like we have a lot here. Trapping water, harmonious. Oh, they're commenting on the harmonious. That's what we resolved. Well, we solved yesterday. Let's see. What did the comments say? It should be something in the. Right. I don't think anybody responded. Let's take a look. What, did I even comment? I think I did. I couldn't remember. Doesn't really matter. We're not here for the comments, but I do want to see if they agree with me yesterday. I think I posted here. Nope. Nobody said anything. Anyway, we'll move on. All right, let's see what I have today. Simplify path. This is a useful one, and I feel like I have done this before as well. All right, I think it's parsing the path string. Absolute path started with a slash to a file directory, blah blah blah. Convert to the simplified canonical path. To the current, double is the parent, and any multiple consecutive slashes are treated as a single slash. Any other format, such as treated as file directory name. Oh, really? The canonical path should have the following format. The path starts with a single slash, and two directories are separated by a single slash. The path does not end with a trailing slash. The path only contains the directories on a path from the root to the target, so there's no period or double periods. Return the. Okay, I already can think of a cheating method. If we want to pass this, I think we can do it. Although I don't really think we should, but what the hell? It doesn't really prevent us from not doing it. Yeah, let's create it first for today, and I don't know if you think of what I'm thinking, but I'm pretty sure that you know what I'm thinking about. We can just pass whatever input into, say, the pathlib, and then the pathlib will do this for us. Well, we need to probably pull up pathlib. That's something I really like, the pathlib. Can it actually produce a canonical? I'm not sure. Let's search canonical representation. Oh, I think you can do str. Yeah. So, we just do path. Yeah. No problem. Oh, hold on. Oh, no, it's fine. It's fine. So we're gonna do import from pathlib import path, and then I'll pass this in. Now this is definitely cheating, but just for the sake of it. So we're gonna return path, and then we do str. I think that shall work. I mean, the benefit of this is we give ourselves a good baseline to see how our solution is going to work. So like if we need to produce any random strings for testing purposes, at least we have a sure solution that can make things work. All right, this is actually very important. Sometimes I encounter this. I have a solution that times out, which means the solution itself most likely is correct. It's just too slow. But these solutions are still useful because they serve as your baseline. When you're trying to figure out a smarter solution and you're not sure if the smart solution covers all the test cases, what you can do is you just produce random test cases and then use the timed out one as the reference to produce the correct answer, and then use your new solution to actually to test your new solution, basically. Because the test case you create is not going to be too complicated. So even if your bad solution times out, it's fine. Hold on. This does not create a canonical path. It does reduce. Really, it does not create a canonical path. Do we need pure path? Oh, okay. It says it does not change. All right, I guess this might not work. This might not work. This might not work. We can do parts. All right, if I cannot see anything more, then it has as absolute suffix. Join path, match. It's a concrete path. Huh. No, I think that's it. That's it for us. We're not gonna do this way. Probably somebody else has a better way of using this trick. We can do OS, right? Wait, what's path.resolve? Oh, it's resolving. All right, let's just this a little bit excursion. We'll leave it here. Maybe somebody in the comments will have a solution. But no, let's do a real one. Let's do a real one. All right. What I think is stack. Usually this is stack. So we push it in. So if the last one, so we push everything to the stack, right? I mean, the last one we can check immediately. The last one is not a problem. The problem is, so if we have a slash, we'll push it in. If I have another slash, if previous is slash, we ignore. It says any number, right? Double slashes. Any multiple consecutive slash are treated. So we can solve that. And it said if 3 dots are treated as file. Okay, let's try 3 dots. I'm not quite sure what that means. So I think this one, let's just do and see what it returns. We're gonna return it empty. That's just for testing. I want to see. It says 3 dots are treated as file name. Your standard input, your standard output. Oh, they changed. this does not happen before. Anyway, okay, so if it's 2, what do we do if it's 2? That means we go to the front, so we're gonna pop 2 out, and hold on. If it's 2, we pop 2 out, and then we make this, and if it's this, we don't count. If it's this, if it's this, then we basically don't do anything because you're still within the same. So we don't have this, and we pop these 2 out, and then we basically pop A out, and then we see this. We do this. We might have a solution. We might. Let's take a look. We're gonna have a stack, and then for how do we determine? So if it's 1 dot, we don't do anything. If it's 2 dots, if it's dot, we probably have to do it like a little bit separate. Okay, let's think about how do we handle dots. Like the slashes we know. The dots, if it's 1 dot, we push it in. Now when we push it in, it has to be dot, 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 right? And we have to just, if it's 1 dot and we put it aside, and then we get another dot, then we know it's 2 dot, and then we get, and how do we know it's 2 dots or 3 dots? So every time we meet a dot, we just run a separate one to make sure how many dots there are. Okay, so for a letter in path, right? And if not stack, or if not stack, let's just do the stupidest and the most stupid. So if it's not stack, then we go stack dot append. We're gonna append it, right? Else, Aleph, this one is a slash, and stack. The top of the stack is also a slash. So I think we can actually do this. This equals this equals this, right? Then we continue. So okay, we skip it. Aleph. So if next time there's a slash, we can get rid of continuous slash. Now the dots are a little bit more complicated. So Aleph, this is a dot. Then we're gonna run a new, Then we cannot use this scheme. We have to say let's say size equals len path, and then we have to use I, yeah, because we're incrementing the index. So while I is smaller than size, we do this append. So we can still do this. Letter is path I. Then letter is this. We say while I smaller than size, if all dots equals this, if letter, if path I is a dot, then all dots, add a dot, while this and the path I equals a dot. And then my dots keep adding until it's not, and then we jump out. I plus 1, and now we jump out. So the path I now is not dot. Okay, now it's not dot. And what do we do? It's not dot. We're gonna compare all dots. So if all dots is one dot, we are going to continue because one dot does not change anything. If all dots is two dot, if it's two dot, then we need to pop twice. So stack dot pop. Oh, what if so the stack has to be like this. Let's say we pop it twice. So what we should do is if it's let me think. We should pop it twice, right? That's what we want. We want to pop it twice because we're gonna go to the previous. So the current state is always with a slash. The stack always has a slash on the top. That's what we want. That's not necessary. That's most likely the case. And then this, then we're gonna pop the slash, and then it depends, right? If we have, say, if we have more than one items in the stack, we'll start with this, and then the first one is a slash, then we pop it. If it's not slash, we add it, and then we have this. So I think the case to really, yeah, I'm just thinking out loud here. So like this situation, what will this one produce? This one produce, say, an error that said like it's not possible because you basically go above the root. Oh, you go back to the root. Well, whatever happens, you go back to the root. So that means we just keep popping, right? We can pop until we reach the root. So what we do is we're gonna pop twice. We're gonna pop one if the last one is a slash. Well, last one shall be slash, because otherwise it's going to be. So what if I have a situation like this? What is going to happen? This apparently is a. This is not correct. It has to. The delimiter has to be the slash, and then we take, yeah, okay, this is not correct. So we start with this, right? And then the current letter is this. If the, all right, so let's look at it like this. If the letter is a slash, right? If the letter is a slash, then we need to find the other slash and accumulate the things in the center, right? Hold on. Let me think about it. Let me think it through. So I say, if it's a slash, right? So current, if it's a slash, and then we go to the next one, next to slash, and then, yeah. So we basically has to find the last slash before the actual non-slash and the first slash. That's okay. So we are going to. All right, let's see. While this is smaller than size, if path I is a slash, how do we do this? No, I don't think this actually really matters that much. Let's do it again. So we're gonna check if the current is a slash, then we're gonna keep going. So we say while I is smaller than size and path I is a slash, then we increment I. So we're gonna move through all the slashes, right? And now we can say, let's say content. Content equals an empty string, right? Content is the empty string. And then while I is smaller than size and path I is not equal to slash, then we're just going to content plus equals path I, right? Actually, I don't have to do it this way. I can just say start is I plus 1 equal to I plus 1. So right now, I is not slash. So we say this is this, and then we say I plus equal to 1, and then once it exits, that means I minus 1 is, so we're going to say content is path from start to I. So this is the current content, right? So we have the content, and now we're gonna check if content is a dot, then we continue. There's nothing to do. If content is a double dot, if it's a double dot, then we are going to pop the previous. So what we do is we find it, we push it in, and then we find the next one, and then we're gonna push in a slash and a thing. So we will always end with the actual content. Okay, so we just make that. So what do we end up with? What do we want to end up with? So we're gonna start. Our start is a slash, right? So now we have our content. So when we push, we're gonna push the content and a slash. Yeah, let's put a content and a slash. So we always end with slash. So we're gonna just pop out the slash and pop out the previous one. But it depends on how many items are there in the stack. So if the stack size, so say if length stack is larger or equal to 3, then we can pop twice, all right? If it's not larger than or equal to 3, then it basically means it's only have one slash in it. So we don't do anything. So we say stack.pop and stack.pop. So basically we're gonna pop twice. And if it's not, then we don't do anything. And then else, which means the content is not a dot and not two dots, it's actual content. Then we do stack. We do stack dot append. So we're gonna append is our content plus a slash. So that's what we're gonna append it. So that's one is it's a slash. And then when it's done, we go up, and then it should be this again. So it always going to be a slash unless there's no slash at the beginning of the thing. Is this allowed? What is going to happen? Invalid path, so it always starts with a slash. Does it say always starting with a slash? So we don't even have to have this check because these have, we've done all the checks here already. All right, let's just delete all the things that we don't really need. All right, so again, overall is I smaller than size, and we go through all the slashes, we find the start point, we go through all the none slash until we find the first slash, and then we have the content, and then we check the content, push the content in. This now I is already in the correct space. All right, so now we just need to, at the end, we're gonna have to pop because we did add a slash at the end of everything. Now we're gonna return, just gonna join them, join the stack. All right, let's take a look. So this one is translating to a slash. Huh. Okay. String indices must be integers. I don't understand why I made this mistake. All right, let's see. That does not look promising at all. Okay. So the problem is, let's see what the stack look like. I think. All right, I think I know. While stack. No, I want to see first. I kind of know what goes on, but I want to see. Oh, I think we have an issue here. So I plus 1. I thought we are. So if it's not a slash, I plus 1, and then we add plus 1, we found it's a slash. And then we go with start to I. I is the first slash. Why do we still have a slash in here? This is weird. This is a very weird. Oh no, this is not weird. This is expected. Yeah, this is exactly what we want. It's just at the end, and then start as I, and then content. Wait, how is we still have the last slash? Oh, because the content. I know. So it's elif content is not a empty string. And we So in this situation, it's not pop because we put these together, which means we shall actually append two things, right? We shall append two things. We shall append the content and we shall append the slash. That will make things easier. We have more pass and we have only one fail. Okay, so yeah, so we remove this, take a look. In this situation, we pop out the. All right, so let's take a look at this. See if we can figure out what happened. So the stack shows is this because we have this, and then we find is this, and then we say it's larger than 3. No, because it's a 1, so we don't pop anything. And we get out and we pop that. So it should be the same thing. If length of it is larger than 3, then we pop the last. Right? No. If yeah, I think so. I think this is what it is. Which means if it's if it's smaller, that means if yeah, that's true. That's true. I think that's true. All right, these are paths. All right, let's make it a little bit better. So we don't have to really do this because it's just continue. We can eliminate this, and then we do this, which means we probably can also put this one up if this and this, then we pop twice. If it's not, and if there is content, then we push something in. And at the end, we also check if we need to take it out. Oh, this is not correct. Why is that the case? We say, so, oh, elif content. So we'll say, so elif content and content is not equal. Now we're putting one dot. Oh my God, this is actually not that easy. The logic. Yeah. I don't like it. Let's just do it this way. It's clearer. So if it's this, and if elif content and content not equal to a single dot, then we do this. I forgot. Yeah. Okay. So another thing is to see if we can simplify this. I don't really think so. We'll have a start, and then we keep going on, have content, we check the content. If it's 2 dots, that means we need to pop, but only pop if the stack is larger than 3. If the stack is not larger than 3, we say otherwise the stack only has 1 slash in it. Say pop the last slash only when the last slash is not the only slash. Yeah. So by appending 2, maybe I can do, yeah, I think I can do stack plus equal to content and a slash. Can I pop twice? Like a Python list pop. I don't think you can pop twice. Man, I mean, you can pop however many times you want. You can pop whichever position you want. Yeah, pop only has position. I want to do it twice. No, it's not really possible. Okay, let's take a look. It's a good amount. Oh, it's going to be. Oh, I never test this one. Let's try it. Ah, we got it. All right. Not too bad. Not too bad. All right. How should we write about this? Let's see. We basically identify or extract the actual contents in between all the slashes. We first find the first slash before the actual content. we first find the first letter of the actual content. We first find the first and last letters of the actual content. Then we compare the content to special options, one dot and double dot. If it's a one dot, we don't do anything. If it's a two dots, we pop the stack. We pop the last two elements of the stack. The stack is configured that it will always have a slash at its top. Of course, this pop will not happen if there is not enough element in the stack to be popped. On, because we visit each one once, visit each letter once, and our runtime is 28 milliseconds, we have an 89% ranking, which is actually pretty good. All right, let's see how other people solve it. This might be a simple question. Well, we have 3 simple in a row. That would be a record if we have 3 simple in a row. I'm not quite convinced it's a simple. It might be a medium, but it's not a very challenging medium, I should say. It's a medium, but it's not a okay. It is challenging. It took me like half an hour, so. Solution is, I'm gonna add this. I like this question. Have I done it before? Yeah, I did it before. Like I said, I remembered. I used Java. Wow, back then I used Java. What a terrible thing I did back then. Oh. What is this? Based on stack. Well, what else could you based on? What did I use before? That's my first iteration. Ooh. Go back one level. Delete. Oh my god, do not remove the last slash. Append. Equals this. Continue. If. Oh, I split it first. Go back a level. Oh, okay. I say this one is good because they use stack. Ah, I know. Well, I'm doing it manually. It could have been done using, oh man, I just realized. Hold on. This is shoot. B, C, D, E, F, G. If I do this, and we say dot split, and if we use this, it can split on all of them. Yeah, it splits on all of them, and actually, if we like have multiple, these will be combined together. Oh my goodness, this is so much easier to handle. And then just every time you read, oh man, come on. Solution 2. Solution 2. Yeah, it'll be much easier to handle if we do it this way. Content Actually, I think content is this. Yeah, content list equals path.split. Just split on this. Yeah, and then we say for content in content list, if content, I'm going to check if content equals this. Now we still need stack. Stack equals this. Kind of want to split. Kind of want to remove the thing there, huh? Yeah, I kind of want to do it, but I think it's all those. Yeah, I think it's fine. Content for content in if content. Probably can do it this way in this. So we don't need a content list, and we know content is always true. And then I don't want too many, so we just say C. If this equals this, and which doesn't follow, this will be the same. All right. Aleph is not a dot. Then we do this. All right. Then I just say larger than 1. Okay, let's check solution 2. Oh, content is not, because it's not content. Yep, pass as well. And it makes it much easier. Nah, I think if this, yeah, I can do this. If content and, yeah. Look, this is much better. I can just like have these two pop. Well, yeah, that's fine. Submit. 32, that's fine, doesn't really matter. And say we can use split to simplify the logic of removing, of stepping through all the slashes. Yeah, I can't believe I forgot about that. Well, I guess it's the same. Look at previously. I saw improvement. I mean, this is supposed to be a little bit hard for me, but yeah, let's see. His solution really pretty good. Slightly different, but it's the same concept. We split on this, and then if stack, and an element is this, we just pop. So we don't really care if we pop it, because we're going to add it back anyway. If it's not, then we just add them. Oh, pretty good. All right, there's nothing more to say. I have the same. I'll have the same solution. Well, I mean, this definitely looks nicer. But we have the same solution, basically. All right, all using, yeah, counting line is useless in this one. Okay, that's it. That's it for today. We had a good one. And it's something that I have done before, but I just kind of remember it. But not 100% remember. I actually reinvented the wheel here. So it's all good. It's all good. All right, we're gonna end up here and then going to prepare for tomorrow. Tomorrow is Saturday. You know, it's gonna be tough. So I'll see you guys tomorrow.